Welcome back. Today we are going through lesson 1-6, which is all about complex numbers. So this is our final lesson in our foundations of Algebra 2 before we get into the bulk of it. And we are going to talk about these complex numbers. So complex numbers are numbers that contain both a real part and an imaginary part. So we've talked about real numbers, we've talked about imaginary numbers, complex numbers combine them. So complex numbers take the form a plus bi. So a is your real part and b is your imaginary part. So when we write those numbers, they have two things being added together. If we have a pure imaginary number, that is where the real part is 0. So you can see some examples there. 2i doesn't have a real part to it, or doesn't appear to. Square root of 5i, pi times I, all of those are pure imaginary. They don't have anything in the real part. Every real number out there is technically a complex number because it just doesn't have the imaginary. It has no imaginary part to it. So when we talk about complex numbers, the set of complex numbers is closed under addition, subtraction, multiplication, and division. So all of them result in complex numbers. So let's look at some operations with these complex numbers. So the first thing we're going to do is add. When we add, we're going to add the real parts together, and then we're going to add the imaginary parts together. So that would give me 4i there. And that's all the simplifying you can do. You can't combine the real with the imaginary. For number 2, we're subtracting. Same thing. We're going to subtract the real parts, and then we're going to subtract the imaginary parts. You can write it as 1i. You are also welcome to write 1i as just I, whatever makes the most sense to you. All right, when we multiply, we're going to distribute. You can multiply a real times an imaginary, so that would give me 21i. And then when I multiply those together, I would get 14i squared. And we should remember that when we have an I squared, that's really -1. So we have 21i minus 14 because that I squared becomes -1. To write it in complex form, we would need to put the real part first. That's 21i. There we go. All right, let's multiply this one together here. So we're going to continue our same ideas with multiplication. So we're going to have -8 plus 4i plus 10, or sorry, 10i, not 20. 10i, and then minus 5i squared. So that minus 5i squared, that is turns into a real part when we make I squared a -1. So that would be -8 plus 5, which is -3. And then I can combine my two imaginary parts to get 14i. All right, let's talk about some properties of complex numbers. So the first one says the addition of complex numbers is commutative. So let's come up with kind of an example here of what that might look like. So if I have 7 plus 3i plus 5 plus 8i, so there's two complex numbers being added together there, I can rearrange that to take the real parts and add them, and then the imaginary parts, add them. So when I do that, I can get the real part plus the imaginary part. All right, the second property is that the addition of complex numbers is associative. So if I take 3 plus 11i and I add 2i, that same thing, right? Associative means I can rearrange where the parentheses are, is 3 plus 11i plus 2i. So I can combine the terms with parentheses that I can actually combine and get 3 plus 13i. And then the last property with these complex numbers is that in the complex number system, multiplication is distributive over addition. So that's proving that we can take a real number and multiply it by two imaginary parts, and that's allowed. So we can multiply the real into that addition of imaginaries. So that would be 15i plus 35i, which would result in 50i. Another way to think about that is that I can combine the parentheses first and still end up in the same spot. So those are your complex numbers. We'll see you next time.